Super. Thank you, guys.
Thank you. Well, we are going to share some slides. So thank you, Sash. So thank you guys for allowing us to do this presentation. It's going to be about chemical engineering, of course. The three of us are chemical engineers. We are members of the Institution of Chemical Engineers, but we are going to talk about now about chemical engineering itself. My name is Daniela de Sousa Parisi, and today are joining me Sajalu Dehal and Thomas Lakey. What we're going to do today, let's just give a little bit of introduction about the presentation. Sash, if you can go to the next slide. So today, what we're going to do is we're going to talk about chemical engineering. We are going to talk about the why we choose to study chemical engineering. What do we do? What are our current roles, and how do we get to where we are? The routes to become a chemical engineer in the UK. What are the benefits of becoming chemical engineers? What are the mentoring opportunities you can have if you choose chemical engineering as a career? And obviously, we're going to leave the microphone open for you to ask any questions that you want to do. Okay, so obviously,
so at the moment, Sarge, I can see the PowerPoint, but I can't see the presenter view. I don't know what anyone else can see. I mean, I can't see the sort of public face of it. I've just got the list of slides down the side, and I'm still on slide.
My apologies.
I don't know if you can switch the views around there.
Let me have a look.
Okay.
Yeah, apologies, guys.
It's okay. Yeah, I could actually see the slides. So
did you? So what can everybody else see?
Okay.
You can see them now. Yeah.
You can see them now. All right, brilliant.
Thank you.
Cheers. Thanks for listening.
So what is chemical engineering? Chemical engineering itself is one of the most broadly based engineering disciplines concerned with the design and operation of industrial chemical plants. And actually, a lot of people talk about chemical engineering as a universal type of engineering. But in reality, a chemical engineer is involved in converting raw materials and intermediate chemicals into more useful forms, which means we are involved in the design, optimization, and operation of systems and equipment using chemical, industrial, biological, and environmental processes. So chemical engineers produce a wide range of materials, things that we rely on every day. For example, from fuels to fertilizers to processed foods, beer and wine, pharmaceuticals, polymers, and so on. And we, as chemical engineers, play an important role developing processes and products that have energy efficiency, are environmentally friendly, and make industries safer. So chemical engineering is a highly practical degree. And as chemical engineers, we apply the principles of maths and science, like chemistry, biology, and physics, to solve problems. So chemical engineers work all over the world in different industries, such as energy, environment, food and drink. We go nuclear, oil and gas, petrochemicals, pharmaceuticals, project management, water, and so on. We go a very wide range of industries chemical engineers can work on. We can work on the next slide now. So, oh, sorry, the one before. So, as a chemical engineer, you could find yourself working on different activities, design and development of chemical processes and equipment, plan operation and management. So you can do optimization of control of industrial operations. You can work in manufacturing and production, environmental management, monitoring and pollution control, fundamental and applied research of different processes, risk management, and so on and so on. Obviously, this information here is what the IChemE has statistically about their members working in the industry, but there are many areas you guys can work on. Okay. Thanks, Sash. So now we're going to talk about ourselves and what do we do. So I'm Daniela de Sousa Parisi. As you can see, it's not an English name at all. I'm a chemical engineer working in consultancy for the energy sector. Portuguese and Italian from family background, but I was born and raised in Venezuela, South America. So I was attracted to become a chemical engineer and specialize myself in the energy sector because I found out this has a wide range of opportunities to develop the career. I studied my bachelor's degree in chemical engineering at the Central University of Venezuela, and after I finished my degree, I started working as process engineer in a consultancy company and designing mathematical models and carry on process simulations for the design of a simulator that was going to be used for a methanol plant to train plant operators. And after 2 years working on that, I decided to move to Portugal to study my master's degree in chemical engineering and industrial engineering and management. After that, I relocated to the UK and I started working at OSL Consulting Engineers, which is a design consultancy company based in Hull, as process engineer almost 7 years ago. So working in consultancy gives you a very good opportunity to solve engineering problems every day, to offer suitable solutions to clients. We are always working to solve problems and find solutions. I have specialized, obviously, in provide consultancy services, mainly in the oil and gas industry at the beginning, but I have developed projects in the LNG sector, and now we're moving more to renewables, carbon capture and storage, waste to produce, biochemical, all of these new sustainable and low carbon emissions processes. What do I do in my day-to-day job? I mainly do equipment design, or process designs in general. So we carry out a lot of process simulations, prepare calculations, and obviously prepare a lot of documentation for batch and continuous processes. Again, process engineers in consultancy are the first people that start developing the process. So we start from scratch with nothing, just an idea. And we start implementing everything from the conceptual phase all the way to detailed design, and when the plan is constructed, commissioning, and is in operation. So it's really challenging, but it's really good because you learn a lot about everything that you can do and how you can put an idea in place forward. I have also managed teams within the organization, so I have been able to have other roles within the organization, apart being senior process engineer, project management, and I'm also developing risk management within the organization. I'm the chair of Institution of Chemical Engineers in the Hull and Humber member groups, and I'm an active volunteer, STEM ambassador, and Women into Engineering and Manufacturing group. So that's me. So I can move to Sash.
Thanks, Daniela. Hello, everybody. My name is Sajli Dahal. I'm currently a process engineer at AEK International. Previously, I worked at an oil and gas energy at ExxonMobil, and I've also spent some time at Vivergo Fuels, which is currently closed, but used to be a bioethanol facility based in Hull. I'm originally from Nepal. I moved to UK 10 years ago and did my A-levels and university and etc. And long story short, here I am talking to you today. I'm currently a volunteer member at the IChemE Hull and Humber members group, and I try and participate at outreach programs, reaching out to students to get more students into engineering, and especially chemical engineering as a career path. On a personal level, what really drew me into chemical engineering was where I come from, there are not many manufacturing industries, so that's always been something that's always caught my attention. And also being a process engineer, I have the learnings that I've had during university, I can apply them across several areas in the industry, from energy to food to just about anywhere, which is really good. My background is a bachelor's in chemical engineering with a year in industry, which I spent at Vivergo Fuels from University of Nottingham, and my master's is in biochemical engineering from UCL, because I really wanted to focus on sustainable bio-based solutions for future. So I am currently a very recent chemical engineer by the schemes of things, because I've only got 3 years of experience, but my experience is very different to Daniela's, because she's based on the consultancy side of things, which she's talked about from a design, to starting up the plant, and once the plant is commissioned, they hand it over to the process engineer who work in the process operations environment, such as myself. So what I do on an everyday basis is I basically combine my technical as well as interpersonal skills to interact with day-to-day operational support of several refinery assets. And this includes, using my knowledge of chemical engineering at the same time using my negotiation skills and troubleshooting skills and communication skills to get the right level of information, to get the right level of facts across different people in the business who may or may not have chemical engineering background. So that's the real challenge when you're working in a process operations environment. I design and lead continuous improvement where I work, and this is based on the Lean Six Sigma framework, where I put in improvement projects to improve the plant efficiency or energy efficiency, improve process safety, and also reduce waste and downtime, which from a production point of view, you're always looking to optimize the process that you've got. Also, I'm a lead in process engineering support to the process safety and process validation aspects on our site at the moment. And additionally, I also develop and manage the process apprentice program in my company at the moment. Thank you. Over to you, Tom.
Thank you very much. Hi, everyone. My name is Tom, and as you can see, I'm sitting here in the cockpit of the Millennium Falcon. Very professional, I'm sure you'll agree. So I am a chemical engineer. I work in research at a company called BP, which is also based in Hull for the time being. Anyway, more on that later. My education was also at the University of Nottingham. So Sarge, I didn't realize you also went there. Maybe we should reminisce at some point. So that was an integrated master's program, which means it was a 4-year course. So I don't have a bachelor's degree at all. Actually, it's like you can start university and you can go straight through and just get the master's at the end after 4 years. Although my second year of my study, I spent a study abroad, and that was in Malaysia, where the University of Nottingham also has a campus. So I could actually go. I did my second year of study and all my modules and so forth in Malaysia, which was excellent fun and a really good experience. After I graduated from there, I went on to do a PhD. This was also in chemical engineering. This is at the University of Sheffield, and my research was in gasification of coal and biomass char, which is a bit like charcoal, using an ultra superheated steam flame, which is a really cool way of saying just really, really, really hot water reacted with carbon, and we're producing a syngas. That was the target. So a gas which is rich in hydrogen and carbon monoxide, which can be used then also as fuels, but in a more flexible way. You can do a lot more with a fuel when it's a gas than when it's a solid. So I mean, aside from sticking it in the fire in your house or in a steam train, there's not a lot you can do with coal and wood outside of a power station. So I now work in the Applied Chemistry and Physics team, which is part of group research at BP in Hull. So those of you who know Hull might know that there's a site called Saltend, and this is a chemicals plant. So BP's focus there is on producing acid and acetic anhydride and ammonia and some other products over there. So it's a chemicals plant. Although my work is only slightly connected to that, we actually do research covering all manner of things that BP does. So most of you will know BP as a company that sells petrol for your car, which is the majority of what BP does, but we do lots of different parts of the value chain there. So the research that I've been doing in my 3 years here has included looking at technologies that are used to clean up natural gas when it's pumped out of reservoirs under the ground. And I've also been developing new products, so new chemical molecules that we want to use as maybe fuel additives, for example, so things which are sold much more downstream, and actually coming up with what a process might look like to produce those things. So I work very closely with teams of chemists who in the laboratory will come up with a molecule that could be, they think that it's got interesting properties, but then we go, okay, we want to now make this in a way which is obviously on much larger scale and is going to be economical for us. We want to make money. So that's where my role comes in. So a bit of troubleshooting existing operations as well. We work a bit like an internal sort of troubleshooting consultancy, new process development and assessments and so forth, as I've said. So I'm very keen on the dual challenge of trying to provide more energy for the world, whilst also at the same time reducing the environmental impact that companies like BP have. Thank you very much. So I'm going to talk then about how to become a chemical engineer. And there are a number of routes where I think certainly the most common is to do some A-levels and then go to university and get a bachelor's or a master's degree, as you can see in the diagram down here. So GCSEs, I think most of you guys will have done. I'm not sure of the age. I think we've got a few going into GCSEs, some of you doing A-levels. Is that roughly right, I think? So there's A-levels, there's or A-level equivalent as well. I myself did an international baccalaureate, which is not an A-level, but a similar sort of thing. And then the typical route is from there you go to university. There are many universities in the UK and around the world that offer chemical, process or biochemical engineering courses. And then you have also the option of further study. So you can leave with a bachelor's degree and go into working as a chemical engineer directly. There are also further study options, so master's degree, a PhD or an engineering doctorate, which are optional, but depending on what sort of work you really would like to be doing. I think Sarge is then going to talk about, oh no, this one's me as well, pardon me. So university courses, as I've said, there's chemical, process and biochemical options. So there are different names for different courses offered by different universities, which may reflect some of the modules that they offer. So you can qualify as or you can graduate as a chemical engineer, but that doesn't necessarily mean that everybody has learnt exactly the same things whilst they've been at university. There'll be obviously many of the core principles will be the same, but there will be small variations around the courses that different institutions can offer. You also have the option of doing a foundation year. So this is where if you're feeling that your maths or your chemistry, or for example, is not terribly strong after you've graduated with your A-levels, you have the option to do a foundation year, which is an extra year before you go into doing your chemical engineering qualification to help to build up your skills before you progress with that. Entry requirements. So this is taken off from the National Careers Service. So you're looking at a minimum of 4 or 5 GCSEs, grades 9 to 4 or A star to C if you're old like me, and or an equivalent, of course. So people who are doing this in other countries might have not be doing GCSEs, but the important thing is to have English, maths and science, with the emphasis on maths and science is going to be very important for any engineering discipline. 2 or 3 A-levels or equivalent, again, including chemistry, that depends a bit from institution to institution. Looking at the UCAS website, most universities are looking for 3 A-levels, and the average, I think, is that they're looking for 3 A's. Now, there are some which are looking for lower than that, but we're not going to lie, chemical engineering is quite a demanding course, and that's the reason why universities are often looking for, quite academically bright people for it. So that's not to say that there aren't other routes in there, but in comparison to other university courses, it is one of the more challenging ones. And then if you're looking for postgraduate, you need a degree in a relevant subject, but that is quite a wide pot. Thanks, Sarge.
Thank you. Thanks, Tab. Right, guys, I'm going to talk about the apprentices, which I'm guessing some of you are interested. So this is an alternative path to getting into to becoming a professional chemical engineer. I myself don't have a background in apprenticeship. I took the university route, but by any means, this is also another alternative that people use to become a fully professional chemical engineer. So what does apprenticeship program offer you? So you get to work alongside experienced staff or process technicians at This again depends on the level of your apprenticeship program. It can start from anywhere from level 3 and then into the more advanced to the degree level 1, that would be level 7. So it all depends on which level of apprenticeship program you're in first and foremost, but you will be paired with somebody experienced, and you'll be working on the plant, which will be more of a hands-on job, and then at the same time you probably will be doing some distance learning and try to get grasp of the theoretical knowledge, and try to take your practical hands-on knowledge and your theoretical knowledge side by side as you go along. So you gain a job specific skills. So if you're in an oil and gas company, you will gain oil and gas specific skills, but by any means, with chemical engineering, you can go across any industry and apply the same level of skill sets, and it is very easy to adapt. One of the good things about apprenticeship program is that you get to earn a wage, you get a holiday pay, and you're learning, you're gaining new skills, and at the same time you might be able to earn a degree in the end. So which is really, really good alternative route to get into professional chemical engineering. And but one thing I would like to highlight is that not all apprenticeships are created equal, and you've got to be careful of what level of apprenticeships that you join into. So just because you gain an apprentice program doesn't mean that you automatically get to become a chemical engineer. To become a professional chemical engineer in an industry, you do need a degree, and not all apprenticeship programs offer that. So if you are interested in taking this route, this is a small point that I'd like you guys to be mindful in future. And depending on the program, like I've said before, it can take anywhere from 1 to 5 years. I think it usually takes 2 years from level 3, but if you're going for a level 7 degree program, it will take you up to 5 years to complete that. And you will firstly qualify as a technician, and then you'll become a professional chemical engineer. Entry requirements, I believe this has come from the National Career Service, from the government's website, on what qualifications you need to get into this. And I believe you need 4 or 5 Gcses at grades 9 to 4, that is A star to C, and also an A level probably to become to get into the NVQ program. So next, I'm sure that you guys are really curious about the salary as well, because truth be told, I was, and this is also one of the reasons why I chose chemical engineering, because I heard somebody told me that the chemical engineers tend to get paid very well. But not just from a salary point of view, chemical engineers tend to have a very excellent job prospects across wide variety range of industries. And you guys are quite lucky, I would say. This area, the South Bank and the North Bank, we've got a cluster of world-class industries in here, from different sectors, from oil and gas to food to consumer goods. There's a lot of world-class industries here, so we are in a very fortunate location here at the moment. So the job prospects here are huge, and not just that. If some of you may be looking into traveling abroad, you can transfer the same skills and work somewhere else if that's what you prefer. And engineers tend to travel a lot as well, so if you're into traveling, chemical engineering might be a career for you. I've also mentioned to you about the high earning potential, and this is the average salary that the National Career Service has published. But again, salary depends on the years of experience, how senior you are, the level of expertise, and the sector you are in, and so many different factors. But on average, that's the 30 to 60K is the soft band on average that the chemical engineers tend to be paid. The job is never boring. I work in a process plant. It is no day is the same day for me. Every day is a new challenge. And what I love about my job is because I'm quite young into my profession, but the amount of challenge and opportunities that I get doing, and the team, I manage a cross-functional team as well, and I wouldn't been able to do that if I hadn't done what I'd done with my degree. And it gives me a lot of responsibilities, which is really, really exciting. And the projects that I get to do as a chemical engineer is making a real contribution in the food sector or a sustainability sector, you know, reducing our environmental footprint and improving the energy efficiency, making things safer. So, you know, you're actually adding a real value to the world.
So thank you, Saj. So once you do your degree, obviously, and you go out to the professional world, what happens? Because obviously you're not on your own. You go a very big community, and that is going to support you. I'm not talking about only the companies. Every organization is going to support you as a chemical engineer, but also the other community of chemical engineers in the country and in the world, in some areas of the world, are going to support you. So obviously the main thing that you can have is mentoring opportunities. As you progress within your career, you're going to be able to demonstrate your professional competence and commitment to the employers, to the regulators, and everybody that depends upon your work. And one of the things that you normally tend to get, at least in the UK, Australia, Singapore, the United States, is getting charter. That means you get recognition for the professional competence that you have. You are also going to be able to keep progressing with you and develop your professional skills, which may not be able on your immediate role. That's something that you are going to keep progressing with time, and you're going to be able to receive coaching and mentoring from your colleagues and other people within the community. You also are going to be able to progress with further qualifications, and you're going to have more training opportunities, and you're going to be able to progress with your continuous professional development. So one of the things that are going to help you to get through it is being a member of the Institution of Chemical Engineers, which is mainly based in the UK, but it's a global professional membership organization for people with relevant experience or an interest in chemical, biochemical, and process engineering. This organization it's a charitable organization, but it has a big community and provides a lot of connections and network of chemical, biochemical, and process engineers. And this community promotes competence and commitment to best practice, organize a variety of technical, practical, and social events, and encourage young people in science and engineering and support the professional development of its members. So you are not alone in that sense. You're always going to be actively connected with a lot of people in your area and a lot of people in the country and in the world. Now, in the area where you're going to be developing your career, also you are going to have a team of volunteers that are going to support the local members. In this case, in the Holland-Humber region, we got the IChemE Holland-Humber member groups, and we, Sash, Tom, and myself as volunteers, we provide networking opportunities for chemical engineers. We promote chemical engineering in local schools and different areas, and we help to develop strong connections with engineers in the region. And we're always trying to organize events that are we know are going to be useful for career progression, for continuous professional development, and we always are trying to keep people connected in the area, and not only the area, all areas of the country. So we share events with other local member groups. So it is a very, very good opportunity to always keep connecting with other colleagues and other people all around the country. So these are advantages, and you also have mentoring opportunities. You can have a person, an individual that can be your mentor all around your career progression. The mentor can be somebody working in your company. The IChemE gives you an opportunity to select a mentor in the industry, so you're not alone. You're always going to have some support in your progression to, you know, get to the goal that you want to be as chemical engineer. So in conclusion, a degree in chemical engineering allows you to work in many different job roles in a variety of industries all over the world, as Saj said. With so many large employers in the sector, there is plenty of scope to progress your career as a chemical engineer, or even if you prefer to work for a smaller company or on your own as a consultant, there is always an opportunity to choose your own career path. The chemical engineering profession is incredibly diverse, so we got engineers and students for multicultural, multidiscipline teams, which is very common within our profession. As you can see, we all three are completely different areas in the world. We probably are different native speakers, and we still communicate exactly the same way. We talk about the same technical stuff, so it's a universal language. Chemical engineer tends to be a universal language. So becoming chemical engineer will give you the opportunity to make a difference and work to solve major societal challenges in the energy, human health, manufacturing, sustainability, etc. So the result of it being a chemical engineer is a work opportunity for those looking for a very interesting, exciting and a varied career. Thank you, guys. Let's open now the microphone for any questions that you might have.
I think we, I was going to say, I think the students have been putting the questions on the chat. I think it might be good to go through.
Yeah. So there's a few here already. So Jordan's asked, what types of jobs would you be doing if you was entering as an apprentice? Because you're not a fully qualified chemical engineer, what are you actually doing?
Great question, thank you. So the first time, if this is your first time working in a manufacturing operations environment, well, you don't know much, so the first thing you'll be doing is you'll be shadowing the guys who do know. So we'll create, and this is pretty much standard across different industries, is to give you a buddy or a mentor, and there will be a formal program to train you up, and you'll be training as a technician, so it'll be very hands-on, dismantling a pump, or looking at a process valve, learning about how the process controls work. It's very engaging, looking at the process control setups, and making little tweaks in the plant. But all of this will be done under supervision and training. So it is a training program, but it is different to a chemical engineering degree because you are hands-on and you're learning from the people, and you're with the tools from day one. Does that answer your question?
Yeah, so Ryan said, so you're kind of learning whilst you're on the job?
Yes, that's right. So the whole point of apprenticeship is to learn on the job. And if you're doing an apprenticeship degree, you learn on the job, but at the same time you do some form of distance or part-time degree to supplement what you learn on plant and learn the theoretical aspects as well. Because when you're learning on the job, you probably are not gonna get a lot of exposure to the theoretical aspects, but you will know that process, the production side of things, inside out. So as you move on towards a degree, you're sort of starting to merge those together.
Fabulous.
Yeah,
so
it's quite a different approach. Sorry, Jen, I was going to add to that. So if you're studying a degree in chemical engineering, which, we stress it is necessary to get the degree in order to be a chemical engineer. And there's a combination of either you go directly to university and you focus on that for maybe 3 or 4 years. If you want to try and do that via the apprenticeship route, it's definitely less common, and it is going to take you quite a lot longer to reach the same level. So a university course in chemical engineering, at least in my experience, it's quite theoretical. It involves a lot of maths and physics and chemistry. There's a lot of quite sort of academic work to do, and actually not very much of the hands-on side of it. So I mean, most of the chemical engineers who I know, it's an office-based job, right? It's not a terribly hands-on. There are elements of it which are, but it's very much a design, process design. This is all done from an office with computers, with drawings and that sort of thing. Mm-hmm. So the apprenticeship side does give you the more practical skills. That is, most of those apprenticeships are aimed at more of the technician type role. And it, as I understand it, it is quite a lot harder. It takes a much longer time to reach an equivalent kind of level for you to gain the theoretical knowledge that you need to be a qualified chemical engineer.
That's right. That's absolutely right, Tom. One thing I like to stress is just because you get into an apprentice program doesn't guarantee that you're going to be a process engineer, because majority of the programs out there is for you to be trained as a technician. So once you become a technician, you operate the plant. Whereas if you're becoming a chemical engineer, you're mostly involved in the design or optimization, process safety, those sort of aspects. So it's a completely different stream. Yes, it is possible for you to become a process engineer after your apprentice, but it's not the same thing. If you're doing the technician route, you'll become a process technician, and if you're going through the degree route, you'll become a process engineer.
Can I add something? Normally, also in the UK, you're going to have your 1 year in industry. So as part of your chemical engineering degree, you have the opportunity to apply to get a year in industry with a company. As Tom said, I know a lot of people that tend to go to office type of base environment, and consultancy receives quite a lot of people in the year industry, but I do know a lot of people also that go to practicality type of operations role, so they can get a hands-on on the practical stuff, that they can learn a lot about operations itself and troubleshooting and optimization before coming back to uni, finish the degree, and then you get through the job, and then you get that opportunity and a level of experience that open your eyes and say, okay, I want to do this job, I want to work on a plant and see on a day-to-day basis what's going on, or I prefer an office-based type of job. You have the opportunity also, whilst you're doing your career, your degree in engineering, to get the option to see and to test on your year industry what do you want to do.
That's right. I did my internship in a production operations environment, and I fell in love with it. And that's what I'm doing at the moment, So every day is a school day for me. I'm still learning. Just yesterday I was troubleshooting a refrigeration system with fridge engineers and things like that. So every day is a school day. I'm learning every day, So it's really exciting to be on the shop floor and watching what everybody else is doing and interacting. And I get to go back to my desk and work out a solution. And you're always interacting with people on an operations environment, but it is slightly different on a design environment. It's more office space, it's more calculations and things like that, but all very relevant. I don't think there's one's important than the others, but it's just different way of doing things.
Yeah, and I definitely recommend, because I didn't have that opportunity. I did my degree and I did a dissertation, a thesis, and jump straight to working on an office-based environment. I didn't have the opportunity to work on a site base. Now, working in consultancy, you do have the opportunity to be relocated to site, because we do a lot of projects with clients, so you can spend a couple of months on different plants. I had that opportunity a few times, but it's really good, so you can see the applicability, the applications, how things are. When you are designing and you design a distillation column, and it's going to be probably 10-20 meters high, and when you see it in reality, it's something completely different. When you put the drawing on your desk, or when you simulate the stuff on your computer, it's really good also to have the opportunity to see it. And obviously apprenticeship programs gives you that option. Doing the year in industry gives you that option. But that doesn't mean you can keep progressing without having that practicality. It's just options that keeps you getting more and more opportunities to understand the advantages of being chemical engineer in the industry.
Fabulous. So how are jobs advertised? They all want jobs for you. They all want to get those apprenticeships and those degree opportunities. So how do you advertise? How does that work?
So, well, I will start myself. We are, as a small organization, we tend to use our company website. We advertise every single piece of work that individual we're looking for there. But now also we're using a lot of social media. So LinkedIn platform is really, really good. We got our resourcing management team that they advertise the job opportunities there. But mainly the company website, that's the one we tend to look for. Now, LinkedIn is a very, very good professional tool to find a lot of jobs that are advertised in the area and all over the world. It's really good opportunity. You can find a lot of options in there too.
For my industry, so it's slightly different for apprentices because we tend to go to like colleges like HETA and Catch, and we advertise internally through them. And if you are looking for like engineering jobs, like process engineering jobs, there are a few different avenues I think you can use. When I was at university, different companies came to my university to, advertise the jobs, and I don't suppose those jobs were advertised outside, so it was just internally through the universities which I applied to. So you can do that, through your own schools or universities, depending on how closely linked you are with the industries. And if not, use social media platforms like Cracker and LinkedIn and Google search. There's plenty of jobs out there. Or if there's a particular industry you like, you can just simply go to their website and look for any careers or jobs advertisements in there as well.
Yeah, I would say a lot of if you've been to university and you're looking for a job after that, there are a lot of companies that offer graduate schemes which are designed specifically for university leavers, and these kind of schemes, they usually take between 1 and I'd say 3 years. They tend to be offered by some of the larger employers, and they have the advantage that they give you a range of experience. So they often involve 6-month or 1-year placements in different parts of the company. So this is a nice way to get a flavor for what sort of jobs are available to you within those companies. I found my job on, I think it was Indeed or one of the sort of typical job sites, the same place you find any other job.
Thank you. Now, Ryan's asked a really good question, but I am going to leave that one to the end because that is a definite end question there. So what skills do I need as well as my qualifications? So skills, massive. What skills would you say they need?
Well, the first one, definitely problem solving. You need to have very good problem solving skills. You're always going to come up with an issue, and you need to try to find out solutions to all those issues that come up to you. So that's definitely a key one. And that there are a lot of other skills, obviously, depending upon the type of job you're going to do. So for example, in consultancy, you need to be a very good team a person that is going to be able to work with teams, so and communicate. So you need to have a lot of good communication skills, and also you need to be able to have a good technical writing skills, because we produce a lot of reports, and that's what we actually show to our clients. But working as a team is key. So this particular type of job, you cannot work in isolation. You always need to communicate with a lot of people. These are, for me at the moment, like the main key ones, but I'm sure Sash and Tom are going to add more.
To be honest, I think the first one, problem solving, what you said, Daniela, it really hits home for me. And problem solving doesn't have to be just from a technical point of view. It could be a personal, it could be interpersonal, relationship management, especially if you're working in a production, manufacturing environment. Things move very, very fast, and there's a lot of shifts and a lot of people that you have to interact with, all with different levels of understanding of what your job is, what process engineering is, and things like that. So you've got to be really good at your communication, team playing, be able to manage different stakeholders, gain trust and things like that. So I think soft skills play a huge part if you're a chemical engineer.
Yeah, exactly right. So I'm also put top of my list is problem solving as well. And I've got a list. So when I was doing my PhD, I actually used to teach not a course, it was a week-long sort of project skills workshop, which all of the first-year engineers would do, regardless of if they're chemical or civil or mechanical or all the other engineers. And this included problem solving, leadership skills, Team working skills, as Daniela mentioned. Presentation skills are also very important. That includes communication, so orally as well as written communication, because I always told these guys, you can be the smartest person in the room, but if you can't communicate your ideas to your boss or to your customers, then it's going to be lost. Other ones are time management. Most projects need to be done to quite strict deadlines. And another favorite point for me here is that you often have to be able to do projects or solve problems without all of the information that you would like to have. So you need to be sort of adaptable in that sort of sense to say, you know what, if I had all this information, this would be easy. Yep.
Somebody's got the microphone on. Can you all turn your microphones off, guys? Thank you. Carry on, Tom. Sorry.
Yeah, so being able to work without all of the information that you would want, and the key word here is assumptions. You need to be able to make reasonable assumptions for what you think a value or a variable is going to be, and document why you think that is. Now, it's sort of like educated guessing, but this is something that you gain with experience, which is definitely hard. So you will always be asked to justify what those are. But the truth is, there's no problem in life where you have all of the information that you need. So I shall stop there so we can do more questions.
Fabulous. And one quick question from Ryan again. So is confidence one of the skills you need? You need to be confident in what you're doing, don't you, as engineers?
Well, yeah, definitely it is. However, I would say, because this is something, obviously, when you're very young, confidence is something that you probably are a struggle with. You are gonna, if you're a person that struggles with confidence, because that can happen, you are gonna be able to build up your confidence as long when you are developing your career. Again, because you're not alone, you're getting support from people. So don't be afraid of making mistakes, for example, because that's part of the way that you're going to learn. Obviously, the more progressing you are in your career, the more you need to be a little bit more careful when you do things. But you are there to learn, and you are there to progress, and you are there to improve your skills and your technical ability to do things. So yes, confidence helps a lot, especially when you are going to start managing bigger projects. For example, as Sash said, you need to talk about with a lot of people. So the more responsibilities you get in the job, you definitely need to get more confidence on how to solve these problems. But that confidence, you're going to build it up with time and experience and expertise. So at least for me, because I was a person scared of everything, to be honest. And even coming here the first time, knowing no one, talking a language that was not my mother tongue, I was completely scared. And obviously confidence is very hard to have it when you are not even in your own environment. So that's something that you are going to build it up if you struggle with. But definitely it is going to help you out progressing your career if you're confident of what you're doing along the way.
Fabulous. Quick question from Saxton. Do you have to take A-levels to be a chemical engineer? I think we've covered that in. You need to take a degree, but at the UTC in our sixth form, we do other level 3 qualifications. So when we say A-levels, level 3s will take you to university as well, won't they, guys?
I think so. Yeah, I think level 3 is a A-level equivalent, so it doesn't have to be A-level. If it's like a transferable degree, it is fine. Because not everybody's going to have A-levels who apply to go to university. So as long as it is transferable, it shouldn't be a problem.
Fabulous, fabulous. All the questions are coming in now, and we've gone over our hour, and we're coming to the end. But thanks, guys. So I've got a question around COVID. So you're working from home. We can see you working from home. You've blurred changed your backgrounds. How are you feeling working from home? Has it affected any mental health of staff? What is your teams doing? We know how difficult it is being at home. Saxon, yes, Thomas Lakey is in a Millennium Falcon. So we need to know, how are you feeling? How are your companies supporting you? And what's happening with your companies? How has it affected you? That's a big question. Sorry, guys.
No, it's okay. Well, I'm gonna start. So in the consultancy sector, probably has not been significant impact, to be honest. All the staff and contractors are at the moment are working from home because, as Tom mentioned, this particular industry is an office-based type of work. We just need to get our computers with all the technology installed in there and all the IT equipment required to keep progressing with the work. So it has not been a significant change. And to be honest, we have had more and more meetings. I have spoken with more people in the organization that I used to work before, because we communicate more often every single day. And that's one of the main things we're trying to keep to cope with mental health, is just keep communicating and talking. So we do have the OSL has a safety committee, so we look for all the safety issues and improvements in the organization, and also with the mental health. The teams are aware that there needs to be a follow-up of everybody. So every single line manager has daily meetings with all the teams and catch-ups to see what's going on. Is everybody coping okay? Is everything is fine? And we keep trying to set up targets every day and every week. We're trying to keep our working time similar, but there is more flexibility, obviously, because people got kids and they need to take care of them. But the good thing of this is the organization gives us a lot of flexibility. So even people that have had to deal with having kids at home, they have been able to cope with it. But I'm not saying it's not challenging. For particularly myself, I'm okay being at home, but I do have colleagues that really sometimes they want to go to the office, they want to chat with people, have a cup of coffee. So even with that, we're doing that, have a quick chat, having a cup of coffee, a cup of tea, and just trying to keep it the same way as usual, so we avoid disruption as possible. But we've been very busy, to be honest, which is good in a way. A lot of projects and a lot of things happening, so there is no time to be bored or tired at all.
Thank you.
On my end, because I work in a food industry, I'm actually at office at the moment. So from my end, I did spend some time at home, to be honest, right at the start, but it was not possible because, food industry, we're key workers, and some of my team members had to be on self-isolation. So I had to be at work. And for me, I ended up getting a lot of work that other people would not be able to do on site. So unfortunately, my workload has increased significantly at the moment, but it's all fun and games. And we do try, we've got a very strict health and safety policy here, with social distancing and things like that. So we're still, keeping on, keep on going, with our production because we do need to feed the nation. But at the same time, we're doing it safely in the most safe manner as possible.
Thank you. And Tom?
Yeah, I've taken my camera off because I'm distracting people.
I see that. They're loving the background. It's a little bit too much here.
Yeah, it's so yes, I've been working from home since early March. As I said, I work in research, so personally, my job can be done very easily remotely. I anticipate that I'm going to be working from home probably until the end of the year for the most part, just because there's very little that I can't do from home that I would need to go to the office for. That said, I mentioned I work with colleagues who are chemists and technicians who do experiments. They run, laboratory equipment and so forth. So a lot of my colleagues are now back at work, and they are doing their bits there, maintaining the social distancing and so forth as much as possible. And those of us who don't need to sort of interact with equipment are staying away for the time being. Regular catch-ups over Teams. So this is where I developed all these skills for having funny backgrounds.
Fabulous. And that's very much like we're doing it in education, daily, weekly calls, team chats, your tutors are contacting you every day. So we're working very, very much like a business at the moment. So the final question is from Ryan. And Ryan, you're going to get some sort of star award when you come back because you've asked some great questions. So how would you sum up your work in one word? Just one. That's so difficult.
It's impossible. I can give 3 words, because there's so much stuff that happens being a chemical engineer and working. I would go for creativity, exciting, and rewarding. These are the 3 main words. I think it defines my work.
Fabulous. Saj?
On my end, like Daniela, I don't think I can summarize it in one word. So I'll give you 3 words from my end. I would say problem solving. Varied, because not every day is the same for me, and challenging, but at the same time exciting. So challenging / exciting.
Fabulous. And Tom?
Indeed, yeah. Challenging is probably the one that I was going to go with, but I could give some other options. Essential, it's integral. Chemical engineering is everywhere. It covers just about every major industry, as we mentioned earlier on. But also, I want to put in sustainable. I think trying to protect the environment and so forth is something which is very much at the forefront of what all of us are doing. So sustainability is very high on the agenda.
So what you guys have just done there is given me a presentation board with creativity, rewarding, exciting, problem solving, varied, challenging, essential and sustainable on it. You're kind of doing my job for me. Thank you.
Well, I have one more, which I think defines the what we do, the 3 of us. I'm saying, research, operations, and consultancy, where is innovation. That's the main key thing. Actually, chemical engineers are trying to work on at the moment, especially with, as Tom said, being sustainable, trying to work for a more sustainable future. So innovation is key chemical engineering now too.
Fabulous. So before everybody goes, can you all say thank you within the chat function if you've got the chat function, or put your hand up so that we can all see that your hand is up, please. Well done. Thank you, guys. Thank you, guys. Thank you. So thank you so much, Daniela, Saj and Tom. That was amazing. Our students really appreciate the time that you've taken. Everybody's saying thank you. There's hands all over the screen at the moment. It's hard to see so many flashes going on. So students, thank you for taking the time. We've got some great stuff from there. If you've got any questions, now that Daniela, Saj and Tom have done this for us, the friends of the school, they're not going anywhere. We've got them forever. That's part of this deal. We didn't say that before, but that is the deal. You are part of us. So we will do something again in the future, and really interesting stuff around university and apprenticeship options and what we can do. So students, if you'd like to leave the chat, then we're going to stay on. Okay, thank you.
Thank you.
Hi, Jin. Sorry, guys, I've got to rock and roll because I'm in a meeting at the moment, but this was really great. I'll catch you guys sometime soon if that's okay, but I've got to go now.
It's okay.
Thanks, everybody. Bye now.